So example number 4 says a hemisphere has a radius of 5 centimeters. What's the surface area of the hemisphere to the nearest tenth of a square centimeter? And B, what's the volume of the hemisphere to the nearest tenth of a cubic centimeter? So the biggest problem with a hemisphere is, well, knowing what it is. If this is a sphere, this is my depiction of a sphere, which is a ball. A hemisphere is half of a ball. Looks like this. Now, depending on whether your hemisphere is bowl-like, B-O-W-L, bowl-like, that means it's not going to have any solid surface here. But if I take a lacrosse ball and simply cut it in half, well, if I'm trying to calculate surface area, then I would need to calculate this circle as being part of the surface area. And if I remember, I'll show you what I mean by that in class. So you just have to be a little bit careful in the wording of the question. So here we're going to assume that we have a solid hemisphere and it has a radius of 5 centimeters. What's the surface area of the hemisphere to the nearest tenth of a square centimeter? So that means we've taken our sphere, we've chopped it in half, we have something that looks like this, and because we're assuming it's solid, we have to include this face as well. Well, that face is the shape of a circle, and it has the formula of pi r squared. That's supposed to be pi r squared. It looks like a fancy, some ugly other thing. So let's fix that. Pi r squared. So if we look at the formula for a surface area of a sphere, look at the whole formula to begin with. I have to flip back to, what page was that on? There it is, surface area of a sphere. 4 pi r squared. But because this is a hemisphere, I divide that by 2. So I can simplify that a little bit. 4 and 2 divide or reduce to 2 pi r squared. That's my half of my hemisphere. But now I need to add in this circle part that's created when I cut that solid figure in half. So I have to add a pi r squared. So really the surface area of a solid hemisphere is 2 pi r squared plus pi r squared, or 3 pi r squared. So remember, you have to look at the wording of the question as to whether or not to decide to include that circle face or not. Now I can simply substitute into my formula. 3 times pi times 5 squared, or 75 times pi, which works out to, on your handy dandy calculator, where are we here? 235. Actually, you know what? I'm going to double check that. 235.61944. What the heck happened there? 6.61944. I'm going to quickly double check that, so bear with me for a second. 75 times pi. 235.61944. 61944. 9. 619,449. Yep. And then round 2, it says to the nearest tenth of a square centimeter. Nearest tenth is 1 decimal place. 235.6 centimeters squared, because it is area. Question B, what's the volume of the hemisphere? Well, if I look at the formula for the volume of a hemisphere, that's not pi. That is 4/3 pi r cubed. Straight up, just cut it right in half. So I divide that by 2. Just need to cut it in half. So you got a couple of choices. You can calculate this out and then divide by 2, or you can try and simplify this formula a little bit right now. If I simplify the formula a little bit, I have to take 4/3 and I have to divide it by 2, which means I have to take 4/3 and multiply it by 1/2, because I flip and multiply with dividing fractions, which becomes 4/6, which becomes 2/3. So either way, you could do whichever you choose. With this formula, I personally tend to just find the volume and then remember that it's a hemisphere. Remember that it's a hemisphere, and then divide it by 2. So that's what I'm going to do. I'm going to go 4 over 3 times pi times my radius, which is 5 cubed. Punch that into my handy dandy calculator. 261 point. No, it's not. No. On clear. 4 divided by 3 times pi times 125 is equal to 523.5987756. Remember that this is a hemisphere, so I have to divide by 2 now, which will give me, divided by 2, the other answer I was giving you, 261.7993878. Says to round to the nearest tenth of a cubic centimeter. That's my tenth here. The 9 makes that 7 and 8, 261.8. And then we have centimeters cubed. There's your volume of a hemisphere. Questions noted at the bottom of the page here for section 1.6. Lots of practice to do, lots of questions to do in order to get proficient at using these formulas, both backwards and forwards. It is really, really important to do lots of practice.